Then I stop it. Bienvenue au séminaire en informatique cognitive à Montréal, virtuellement. Ça me fait plaisir d'accueillir Andy LÜCKING, le point fort, mais actuellement il est à Hambourg pour cette présentation. Il est professeur de linguistique ainsi qu'informatique à l'université Goethe Université de Francfort. Et puis, il est en effet linguiste ainsi qu'informaticien. Et son thème sera la sémantique gestuelle. Et puis, je vais dire quelques mots à propos de ça en anglais tout à l'heure pour un peu encourager Andy à étirer le thème un petit peu large, plus large que les LLM. So welcome to Montreal, and I welcome Andy LÜCKING for the first time actually in Montreal virtually. So I hope there will be a real time that he comes here. He will also, we've just spoken about it, he will also be one of the speakers in the summer school that will be taking place in the first 2 weeks of June on essentially this same topic, but extended wider. I'll send information about how it's extended wider. But what I want to speak about now actually is gestural communication and gestural semantics and grounding. Andy will be, something just jumped in front of me here. What's going on? All right, can you still hear me?
Yeah, so I can hear you.
So I don't know.
Your video seems to be frozen, but sound is working.
That's weird. I have to do something. But you can still hear me, and the recording is still going, I hope. It says that it's connecting, but it's not connected. Besides Andy, so let me see. I'm going to put on another video and see if that one's working as well. Why is this happening? I guess this means that this is not being recorded yet. I turn this off and try another connection. I can do the whole thing again. I'll probably have to record again. Connected to the internet. Why? Connected by the other one. Okay, maybe I have to record this through here now because I can't. Sorry about this. I don't. Ah, it's still working. It's still recording. Well, I guess that's good. But one of my computers is not connected.
There's a light blinking saying recording.
It is recording. Okay. Well,
so,
then you won't be able to see my face because I was logged in another way. But never mind. Okay, so you see my name in French. Andy is here to speak about the question of gesture for LLMs. It's called large language models, and their gesture is also an aspect of language, and it's a form of language. And moreover, there's a lot of interest in the origin of language and the origin of gesture, especially in the context of with large language models, we talk about multimodal approaches, but what does multimodal mean? We know that vision and touch and movement are all sensory motor modalities, but it's not clear that what ChatGPT is doing is sensory at all. It's not. You can talk about multimodal LLMs, but if you don't talk about multimodal LLMs, it's not clear that an LLM is a mode at all. I don't know how Andy feels about that. But the question with gesture is this: with gestural communication, non-linguistic gestural communication, there is no problem of reference because you're either pointing to whatever it is that you're gesturing about, or the gesture is imitative. It resembles what you're gesturing about. Language, real language, propositional language, is the one that has the problem of reference. But to have the problem of reference, you have to have language. And language consists of propositions, subjects, predicates, and truth values, among other things. That's when the issue of reference comes up. What do you mean? What are you referring to when you say the cat is on the mat? So with that, that's all I want to say by way of provocation. With that, I want to pass the gavel to Andy. Welcome to Montreal.
Yeah, thank you very much. And so I start sharing and hope you can see the title slide, which just shared.
We see it very well.
Okay, very good. So I will talk about gesture semantics, and calling it semantics is not arbitrarily really chosen, as you will see in a moment. And from the gestures that there are, we focus on pointings and iconic gestures. So I just give you a kind of tour d'horizon on these kind of things from a linguistically motivated point of view. Or perhaps I'm going a bit fast, so feel free to stop me, interrupt, and ask questions in between if you have one. So since you probably don't know me, it's good to give you a brief background from the perspective what you can expect in the next few minutes. So I'm trained as a theoretical linguist with a focus in formal semantics, you know, these possible worlds stuff. But as part of opening up to a dialogical perspective, which is what automatically comes if you are dealing with gestures, they are part of dialogue. Other formal frameworks seems to be more appropriate, like a type theory. This theoretical background is kind of complemented by computational linguistics work. So computational linguists and computer scientists in general, trying to get things actually to work, which theoretical linguists usually do not do. So the basic thing is that communication is not just language. So I brought you a little picture here, and this is just a static picture, even in black and white, but I think you can already tell a lot from it. You automatically connect it to an event and possible explanations, and to interpret what happens there. The reason is that people not just use language, regardless of written text. They use spoken language in addition to facial expressions, to manual gestures. They use prosody, so it's not just so intonational patterns. They express emotions. They use spatial configurations, you know, standing in distance, getting closer. All this is important for communication. Some even say that language itself is multimodal. We don't have to puzzle about this. Sometimes it's useful to make a distinction here and say that communication uses language and other modalities as well. And that's the sense in which multimodal is used here. We have one mode of communication, the verbal linguistic one, and other modes like gestural, facial expressions, and manual gestures. Another starting point, perhaps worth pointing out, is that one can look at LLMs or artificial intelligence in general from three perspectives. First is the tool perspective. Here, an AI tool is, or an AI application is used to just solve the task at hand. In linguistics, this is usually some annotation or pre-processing of text data. Then there's a more interesting sense, namely an AI or LLM, as I will say in the following, for social interactions or for information-seeking purposes. I think here is where ChatGPT is placed in the first place very well. This is also the focus of the Turing test. Does our companion behave like a real human? But this has to be distinguished from LLMs used as cognitive models, where they actually try to implement our cognitive theories in the sense of reverse engineering cognition, for instance. So this is, I think, important to distinguish. And I will not say much about the first one, the tool use. So we will zoom in on pointing gestures and iconic gestures, which is this circle interaction aspect of LLMs. And we will try to get some conclusions, maybe some cognitive inspired conclusions in the end. So that's it. Let's jump in. Here's a simple example. Look, a man is stealing my lemons from the garden. So this sentence is true according to traditional views of reference, just in case if the entity provided by the pointing gesture is stealing lemons from the garden. So for those of you who are linguistically interested, just a side remark, the indefinite noun phrase a man has a specific interpretation here, which is pretty nice due to the Deictic operator look. So far so good, but what does it mean, the entity provided by the pointing gesture? In order to make sense of this, we conducted an experimental pragmatics study where two participants were engaged in an object identification game. You see one of them sitting at the short side of a table, the pointer or speaker, and he or she has to identify objects which are laid out quite systematically on the table in front of her or him. The other participant had to identify the intended referent, of course. And as you can see, the pointing participant was equipped with tracking equipment. So we were able to kind of measure the pointing behavior and simulate it subsequently. What does these experiments came up with? So at first, we have to look at identification failures, which is the number of instances where the recipient were not able to correctly identify the intended referent. And this is the figure for the run which has been done without speech. With speech, it was quite easy for the participants to resolve reference. But without speech, we see that there's an increase of errors starting from row 4 onwards. In the first 3 rows, it was quite easy because the pointer could touch the objects that were in reach. And yeah, there are up to, it's not nearly the half, but 40% of instances at distance were not able to correctly be identified. And this doesn't look like reference is very direct, as claimed in some semantic theories. You notice a decrease in the last row, row 8. This is a nice example of what can be dubbed gestural hyperbole. The last row is kind of distinguished because it's the last row of the table, and people exploited this by pointing way beyond the table, so indicating exaggeratingly that they are referring to the last row. This helped, obviously. So using the tracked motion data and plotting them on the table gives rise to so-called backplots, so areas encircling all the points on the table where the pointing beam hit the surface of the table. And somewhat interestingly, they nearly never hit their intended target. Here are the backplots for 4 selected objects, the 4 gray areas. And if you look at object 3/5, this little screw over here, you see that there's a wide range of pointing beams, not even close. So again, this doesn't look like very direct mean of reference. It's at best some inference involved. So a pre-semantic, pragmatic inference that the object pointed at is the object which is kind of close to the idealized pointing B. But if you idealize these back plots a little bit further, you notice that they are nearly elliptical. And if you know from your math classes, if you intersect a cone with a surface, you will get elliptical structures. And this is exactly the idea behind pointing gestures, that they are not resting on a kind of directly beam model, but they rest on a spatial model comparable to a light, a pointer, where some area is selected. So in some reference is not direct, but rests probably on a figure ground model. So the verbal demonstrative, this is an attentional index which directs attention to the pointing gesture, and the pointing gesture in turn opens up the search space in which the intended referent, the index, is to be found. Okay, so far so good. This is not yet very interesting. So we add some spice by having a look at deferred reference. What is this? Well, the object pointed at and the object referred to may be different things. Here's a simple example. The mannequin over here points at a bookshelf where two books, and the upper book is selected by the pointing gesture. It's part of the search space, the pointing cone. And now the mannequin can say, this is my favorite author. But there's no author in the shelf. It's a book. It's easily resolved. It's a metonymic relation between books and their authors. So deferred reference exploits some salient relation which obtains between an index and a referent. If we add another object, which is a possible index, so thing pointed at, we can get a clearer picture on what is going on in these cases. So suppose the situation depicted here. You can say, this is my favorite author, as we just had, and you are very likely referring to the upper book. You can say, I want this for breakfast, and you very likely mean the cup, which is also on the bookshelf. You can also say, did the carpenter build this? And then you probably refer to the bookshelf itself. The crucial observation here is that the interpretation of the pointing gesture, so the object which is referred to by the pointing gesture, depends on the verbal description we are using. So the index, as we call the object pointed at, is partly determined by the referent, so the object given in speech. So we have an interaction between the spatial constraints of our gesture and the descriptive constraints given in speech, and they both single out if pointing is successful in order to identify a single object. And this is quite diverging picture from what has been populated traditionally in linguistics and philosophy, where it has been claimed that we first identify the index, then find a salient relation, and can move on to the referent. So this is obviously not what people are doing. They use these constraints even in order to identify the index. Okay. Let's look what ChatGPT says to this kind of examples. There's a question?
I can't tell. Can you hear me?
Yeah, I hear.
One book in
If there's someone, if someone is asking a question, say it out loud. Otherwise, please turn off your microphone.
I think it's Max P. I think it's just his microphone that is open.
Okay, go ahead. Sorry, Andy, go ahead.
Oh, no worries. So ChatGPT in its current form at least doesn't have eyes and arms, so we have to verbalize the example. And so the gray box has the prompt and the greenish one has ChatGPT's answer. And the prompt is, in the following scenario, George is pointing at a table with a cup, an egg, a fork, a knife, a book, a table, a spoon, a newspaper, and car keys on it. He says, "This is my favorite author. Provide a short answer as to which object George is referring to." George is referring to the book on the table, as his favorite author is typically associated with the content of books. Yeah, pretty good. So, deferred reference seems to be no problem, at least if we verbalize it. Let's look at a more intricate use of pointings, namely discourse pointings. These are pointing gestures which are usually addressing your interlocutor, so you're pointing at the person you are speaking to. And I think in many cultures, this is considered to be a rude behavior, but it has some discourse functions, as in the example shown here. The context is route description, and the one to the left, the router R, has explained the route to the follower F. And we are now in the state that F is recapitulating the route which has just described to him by R, and he's trying to recall a landmark which has been described at a certain point of the route in turn 1. These are actually German data, but there's an English translation behind the slash. So there's and now he's hesitating because he doesn't recall which landmark there was. And the other interlocutor jumps in and continues the sculpture. And by saying the sculpture, pointing at F. And this was actually apparently the right choice, as F agrees, the sculpture on top. So this kind of gesture is known as common ground gesture, because it indicates that the discourse referent, so the thing the interlocutor is speaking about, is indicated to be part of the common ground, so this shared knowledge of the interlocutors already. And I thought this is a very indirect and intricate use of pointing gestures, and there's no chance that ChatGPT can make sense of this. So let's try it. Here's the prompt. In the following scenario, Paul is recapitulating the route which has just described to him by Lisa. Now he's trying to recall the landmark at a certain point of the route. He's starting an incomplete utterance. Then there is the. Due to his hesitation, Lisa completes the utterance while pointing at Paul, the sculpture. Provide a short answer as to what kind of gesture this is and what the gesture can mean in the context of the utterance. So the answer is, the gesture is described as a completion or prompting gesture, where Lisa assists Paul in recalling information by providing the missing word or phrase through a physical cue. In the context of the utterance, it indicates that Lisa is helping Paul remember the landmark mentioned earlier in their conversation. So I have to say, I was pretty amazed by this answer because this was quite good. But the prompt was very detailed. So maybe less context would produce a worse result. So let's try this. In the following scenario, Paul is talking to Lisa. Paul, then there is the Lisa, while pointing at Paul, sculpture. Provide a short answer as to what kind of gesture this is and what the gesture can mean in the context of the utterance. In this scenario, Lisa's gesture is the completion or prompting gesture. She's helping Paul complete a sentence by providing the missing word, sculpture. This gesture indicates assistance in communication and clarification of Paul's intended message. So I think this is still a pretty good answer. But some aspect of why the answer is good is not by ChatGPT recognizing the pointing gesture as discourse pointing, but by making use of the ellipsis points. These points here and here indicating incomplete utterances. If we remove these ellipsis points, here and here, they are missing, the answer gets significantly worse because the gesture is now mistaken as a correction or clarification gesture. So it's not recognized that there is a continuation, but it's ChatGPT thinks there's a correction or clarification going on. So some care has to be taken here, but as an interim upshot, we can say that since ChatGPT is not a physical robot, it cannot trivially engage in deictic interactions. It does not have eyes and arms, so to put it bluntly. Nonetheless, if you put pointing situations verbally, ChatGPT can easily deal with deferred references, which rest on word knowledge, so it can resolve metonymical relations. And it probably has enough word knowledge. That's not the big deal for LLMs. The cognition of discourse pointing so interacts with correctly typographically prompting. So as we have seen, ellipsis points are exploited, but I don't think that's a very serious issue, just but it's an anecdotal evidence in any ways. But given this, so reference by pointing gestures does not seem to be a linguistic challenge per se, but more an engineering challenge by equipping LLMs with some vision system for scene perception. So we have to move on from what Hannard calls T2 systems to T3 systems, since we need to have speech in addition to some visual perceptual module. But given this, I think it's just an engineering problem for scene perception. So you have to identify the pointing cone, and then it interacts with speech, and even the purely textual ChatGPT is able to do this. So let's move on to probably a more interesting topic, namely iconic gestures, which are claimed to resemble the thing which they are about. Here are two examples, two outstanding uses of iconic gestures. They can be used as demonstrations. Then the house is like this, and a rectangular gesture is drawn. So in a sense, the whole information of this multimodal utterance is carried by the gesture. And we interpret the utterance as a whole in terms like the house has a rectangular layout or something similar. In another use, iconic gestures can enrich the semantics provided by speech alone. The example on the right is an instance in case, I think that should be staircases, and the gesture makes, the speaker, the gesturer makes this spiral movement with her right hand. And we can infer that she is speaking about winding stairs, spiral staircases. So we have demonstrations where gestures carry the crucial aspect of meaning, and we have enrichments where gestures add to speech meaning. Are, as I said, outstanding things. Usually gestures are just kind of redundant with speech. They just depict what is talked about. Like in the enrichment examples, the speaker usually would say, I think that should be winding stairs, and there's no problem. But just as a side remark, this is more catchy. So the crucial thing is, how do we come to understand the multimodal meaning in a way which is richer than speech alone? What does visual meaning add to linguistic meaning or verbal meaning? How does it come that we interpret this gesture as rectangular or something along these lines? How does it come that we think this is winding? So the answer probably is that we rest on perceptual classification. Our gestures introduce a perceptual model, so a kind of idealized geometric object. And this object can be given as input to a perceptual classifier, which outputs the correct label. You see that I've used ones here, so it's just a binary classifier, true and false, 0 and 1. They should be probabilistic, but this is easier to present. So why is this interesting in terms of semantics? Here's what truth-conditional semantics usually say about visual scenes. Here is a bird which is stealing ice cream from the man, and the respective utterance, the bird is stealing ice cream, would give rise to a proposition that there is a stealing event where the stealer, the agent, is a bird, and the object stolen is ice cream. And our scene pictured on the left is an object an event which makes the proposition true, just in case our situation is part of the set of propositions of our truth-conditional semantics. So this is all standard, and part of this standard picture is that the meaning of a one-place predicate, like bird or ice cream, is modeled as a function from possible worlds to sets of entities. This is the direction of meaning from our predicates to the world. But we've just seen that we need a different meaning function, namely perceptual classification. And this seems to go the other way around. We see a white moving animal over here, and we classify this as a bird. And we see these ice cone and classify this as ice cream. So this function applies to entities, and they return a one-place predicate. So this is just contrary to our meaning function we are used from our formal theories of semantics. And this is the challenge visual meaning poses to standard semantics, because these kind of notions seem to be incommensurable, at least vice versa. Yeah, sorry, at least at first view. So, and we need both of these aspects to make sense of iconic gestures. So going back to the houses like this example, we can give pretty standard truth conditional interpretation, but now we enrich our proposition by spatial representations. So we just extend our models in which we interpret our propositions by some mathematical theory of space. So vectors are very appropriate means for doing this. So then we have this pretty standard thing, like an event which has a house, but this house projects a space, a region, a really three-dimensional, Newtonian space. And from the gesture, we get also a spatial representation, and the multimodal utterance is true if we intersect both of these spaces. So it's a very, very traditional, conventional extension of classic semantics. But at the price that we have to introduce so-called dual-coded propositions, so propositions which contain perceptual, spatial things and linguistic items. But additionally, we have our perceptual classifiers, which assign labels, linguistic labels to these gestures. So this shape can trigger labels like rectangular, U-shaped, tape, this object, or whatever. And this gives rise to informational evaluation, as we call it. So if we think this means rectangular, then we interpret the multimodal utterance as the house is rectangular. If we interpret this as U-shaped, then the house is U-shaped. This is just a side note, important, since unless gesture is evaluated in such a way, it remains kind of sublinguistic. So it cannot really interact with speech. This can be seen in negation. So it's nearly never possible to negate a gesture without informational evaluation. So just a side note for those of you who came across gesture semantics at some point from a linguistic point of view. In dialogue, this can be easily managed because there is a very well entrenched mechanism of grounding and repair. So if there is something which raises questions in one of the interlocutors, then he will just pose a clarification request. And gestures can also be the object of such clarification requests. And this clarification requests can address the meaning of a gesture. So how to evaluate. Do you mean rectangular? And then the speaker has the option to say, yeah, I mean rectangular, or no, I mean U-shaped. So there's a natural collection to discourse, which can make this informational evaluation explicit. So how is this going to work? So the reason is that over the past 40 years, I think, at least in cognitively oriented linguistics, it is quite consensus that a lexical entry does not only consist of phonological, syntactic, and semantic information, but it also has some visual or imagistic representation. It doesn't need to be partitioned in this simple attribute value matrix you see here on the left-hand side. It can be, of course, different, but just to give you the basic idea. And this visual or imagistic representation in many approaches is inspired by the differential model of David Marr, who developed this 2.5 respectively 3D models. So these nesting figures consisting of cylinders with adding details at every level. But these Marian models are mainly developed for the perception of objects. So, but all these gestures we have seen are movements, biological movements. So maybe a better cognitive understanding can be drawn from the psychophysics experiments by Gunnar Johansson and colleagues, who did these things. He equipped participants with little lights on the joints and let them perform movements like walking and running. And if you display only the lights, as you can see here in figure B, so movement patterns of points, if you want, to participants, they were perfectly able to classify the movement. So if it's walking, if it's running, and so on. So why are they able to do this? Part of this model is a vectorial representation of movement. So the hip level, the A, is can more or less be reduced or factored out to a horizontal movement. And the B level introduces this pendulum movement. So in sum, we can give what can be called a conceptual vector meaning for walking. And that's the idea, is the clue to perceptual classification, even in case of gestures. So if you have something which complies to this abstract vector model, you are allowed to interpret this in terms of the linguistic expression which is associated with this vector model. But it's not that simple, because gestures are not real world events, they simulate events. And part of this simulation is that they can be silent or not displaying certain abstracts, mainly the arguments which would be involved. So it wasn't much a great deal with walking, but think of a throwing gesture. So please think of this little image here on the right as indicating throwing, like this. You know, you move your arm forward and open your hand, so you let something fly away. But obviously, I'm not throwing away something when I do this. I'm just simulating a throwing event. There is no object which I'm throwing away. You can make sense in terms of what can be called visual presuppositions. So this is an assumption you have to make in order to interpret this gesture as throwing. You have to presuppose that there is a virtual beam which is thrown away on a virtual trajectory. And this is the reason why, at least for gestures, iconicity is probably not just simply structure sharing between the form and something outside in the world, but iconicity is mediated by perception. So iconicity is not resemblance in the sense that something is similar to something, but something looks similar. And these are different things. So if we take this serious, we have to modify semantics a little bit. We have to replace this kind of precompiled walk predicate by our classifier, which returns true. So this is one attempt to combine truth conditional interpretation and visual interpretation in one system, giving rise to this architecture. We have in blue a kind of traditional the model resting on positions and truth conditions, but spatially extended. We need this to interpret some spatial predicates in language. But this is also the interface point to gestures which introduce these perceptual or iconic models, which are intersected with spatial projections of our linguistic discourse reference we talk about. And this is complemented by this perceptual classifier thing, which lifts gestures to the linguistic level in the first place. And this is also the connection to the lexicon, where presuppositions, inferences, and so on can be drawn.
Can I ask you a question, Andy, just for clarification? Because many of us are not familiar with these formal models. Could you say again in ordinary English, what's the difference between looks similar and is similar?
Yeah. I just go back to this slide. I think this example may help to explain this. So here we have a movement which looks like that I'm throwing away something, but I'm not actually throwing away something. So in literal terms, that's not throwing, because there is nothing which is thrown away. But nonetheless, the perceptual image which arises, so which looks like something, evokes the impression of throwing, because the movement between the real world throwing events where actually some object is thrown away and the simulation look the same, apart from the thing which is thrown away, which is not part of the simulation, but part of the real world event.
Maybe I don't want to make the question sound ontological, but I want to know that in both of those examples where somebody's really throwing a ball, so that's what he's doing, and it looks like he's doing that. In the other one where it looks like something's being thrown, but nothing is being thrown. What if we forget that there's a question of observers and things like that, and simply say, is the nature of looking similar to something and being similar to something somehow ontologically different?
Yeah, I would say so. Let me think of another example, which is probably better. Rolling. If you think of a wheel in physical terms, and you try to follow a point on this wheel, it will go in this way. Right? Yeah. But if you try to make a gesture which mimics rolling, you probably will make this movement. Because, well, we have the idea that rolling is something which goes in circles, and you produce a circle when you depict the rolling event. But that's not what, but this part of going back will never happen in reality. So there's a kind of a difference between what things may look like and what things actually are. And this may be an ontological difference, regardless of this truth conditional framework where this matters, of course.
Okay, thanks. Good. Please go on.
Okay, we have already covered the semantic part, which tries to make clear what is needed to interpret gestures and make sense of them. So let's go back to the example and let's look what ChatGPT is doing with this and coming to a conclusion. So then the house is like this. As we've seen the verbal demonstrative, this shifts the attention to the gesture, and the gesture demonstrates the shape of the building in the first place. We can interpret this, but we can also evaluate it in linguistic terms. So we can have the impression that the layout of the house is actually rectangular. So here's the prompt for ChatGPT. In the following scenario, Jane meets someone. Person says, the house is like this, and simultaneously gestures as follows. The index finger of the right hand is stretched, the other fingers are curled. The hand with the stretched finger is moved away from body, towards left, and finally towards the body. provide a short answer as to what kind of gesture this is and what the gesture can mean in the context of the utterance. So the answer is, the gesture described is a demonstrative or illustrative gesture used to visually represent or mimic the shape or form of something. In the context of the utterance, the house is like this. The gesture likely represents the shape or layout of the house being described, indicating size, orientation, or structure. Okay, but I wasn't satisfied. Quite a short answer as to what shape the house has. Based on the described gesture, the house has a rectangular or elongated shape. So, again, pretty cool. So the answer ChatGPT gave were quite good, although they have nothing to do with what is involved in gesture semantics, which I just described. ChatGPT works only with text data. Now, what's going on here? So the first observation is that probably LLMs do not generalize well beyond the training data. In particular, they will not kind of invent other modalities like gesture where just trained with speech. That's obvious. So the only explanation for the observation that LLMs can deal with gestures if we describe them is that they have enough descriptions as part of their training data. I think the crucial question here is whether everything is already described and available as training data for our LLMs. This point was touched in the discussion in the second to last talk, I think. This has an interesting side aspect, namely that when we write about and publish about gestures and maybe on grounding and stuff like this, we are producing more and more training data for our large language models, and we help learning them, even these kinds of things. So only the text-based input describing gestures seems to be enough that LLMs can deal with the descriptions, at least. That they can't produce gestures, it's a triviality because they are not embodied. They don't have robotic bodies. So from this, probably we should not trap in a cognitive fallacy. So far we have looked at LLMs at these social interaction things. So I can, if I describe gestures, I can talk to ChatGPT using these gestures. Well, it's a bit more tedious than just producing a gesture, but it kind of works out. But from this, the companion view, we should not automatically shift to the cognitive view. So if you make a model that does something that looks like cognition, then it could be cognition. It's called fallacy, the fallacy of Makism. So it doesn't need to be a cognitive model even if it works. Why is this the case? So I think we all agree that LLMs are not cognitive systems in the sense that they have understanding and consciousness and things like this. And they are obviously not grounded in sensory motor features and attentional and emotional features as well. But is this needed in order to process speech? Probably not. There has been some discussion in terms of the embodiment movement in cognitive science, where it has been claimed that the format of cognitive representation, the format of concepts is the bodily format, namely sensory motor features. But nonetheless, we have evidence for more abstract, more linguistic processing. So we can turn this around and ask, how is the conceptual system able to disengage from the sensory motor system? Or this has been termed the linguistic shortcut. The linguistic associates can be viewed as computationally cheaper than simulation. So associations between linguistic forms are quicker to process probably than to simulate sensory motor situation models in order for understanding things. To put it graphically, so we have our linguistic labels which are associated and they can be grounded in sensory motor features, but you don't need this step from the blue to the red area to process language. If we follow some claims by mainly Peter Gerdenfors, we can think of our inner world as consisting of spaces which have topological and geometrical structures. We've just seen one such space, namely the locomotion space for movement, which we use to interpret gestures. But there are other ones as well for color, for emotion, mainly maybe conceptual spaces in general. These can be grounded. This can be grounded in physical features, sensory motor features, whatever. But these spaces have specific axes, and these axes can be labeled by meaningful labels. And in this sense, the dimensions which give rise to meaningful interpretations in terms of distances according to each other within this space can be seen as maybe linguistically grounded in descriptions. This was one aspect of the talk on distribution and semantics, which we had 2 weeks ago. If this is true, then LLMs can be compared to the Baron of Münchhausen because they can pull oneself up by their own bootstraps. So even if they are circular, they are kind of able to deal with ungrounded linguistic labels. And as a conclusion, I think there's the question of the limits of LLMs. And the question probably is whether language is the limit. Is there something we can't talk about? So is there something we can't provide training data for? So if the LLM will get training data for something, it will be able to at least be a companion for this topic. So Wittgenstein said that the limits of my language mean the limits of my world. So just to end on a philosophical note, probably the limits of an LLM's training data mean the limits of the LLM's world too. So with this, some rough, broad conclusions. I thank you for your attention.
Thank you very much.
Forward to any questions or.
Very good. Let me change to a configuration where I can see people. Please, if you want to ask a question, yes, we've already have. Go ahead. Go ahead, Manu. I say your full name.
Hi, my name is Manuela Gonzalez. I am one of the researchers at the MBMC. I'm doing my PhD at Concordia, and I am leading a project where we're trying to identify cues regarding ambivalence and hesitancy in behavior change and trying to train AI to identify it automatically using multimodal data. So your presentation, Andy, was extremely relevant and interesting. I love how you filled out all of the gaps on how we create a bigger picture with the information we have and the way you showed the process. I come from a background in psychology, so I have a lot of gaps where you seem to have a lot in computer science And I've worked in argumentation and in understanding how emotions influence our language and the way we make decisions as a whole. So this is extremely relevant. I have a lot of questions, especially regarding how can we tag properly those things we see, and how do we create the code specifically to understand multiple aspects of one image. So I don't know if this is the space, or I don't know if I can email you and we can have a quick talk where I can tell you more about our project and how it relates.
Yeah, so your question is about the correct label of whatever you're interested in. Yeah.
Because you were when you were talking about how you were describing the architecture and the way the house was laid out, especially, is what are the parameters that you're taking when creating the codes? And you mentioned that this was something you had discussed in a previous meeting. I wasn't here, but it's the idea that everything has to have a label and something has to be named and before it can be recognized.
I think you can recognize things without labeling them, but obviously, if you want to talk about this, you have to use a label to describe it. And yeah, is there a real label? I think the range of this question is learning a language within a society, ultimately. Because we have this visual input and we have kind of top-down pressure to use the right word for the right thing. You know, we all have parents and they often say, that's, you know, that's not a spoon, that's a fork. Or, can you pose the question in a full answer? Something like this. And this interplay of having a socially grounded communication system like a language with normative impact, and an adult, a kid which learns this is, I think, the clue to getting right labels. Yeah, it's from the modeling perspective. This is, yeah, it's a challenge. We are starting to implement the iconic gesture perceptual classifier, which is also a bit tricky because you can't use simple events or human object interaction data sets, just for the reason I explained, because these visual presuppositions, the objects actually dealt with, don't play a role. So you have to abstract over this. So it's computationally already a little bit challenging. But on top of this, in the end, if you want to explain everything, you have to connect this to language learning. So that's the answer on how the labels come into being in the real world. If your question was about, I don't know, annotation for your project, I think you have to make up an annotation manual and make some definitions and decisions.
And how necessary is the specificity? Like, because I think it's very wise when you said, like, we don't need to note everything and every part in order to become a whole, right? There are some gaps that we can let in the system, like, fill out. But will that modify how well does the AI does its job to weakly annotate the data? If we give too much of a weakly annotated data, do we just leave out the possibility for those mistakes, for those in-betweens that are not necessarily identified?
Yeah, that's the problem of training data. So if it's true that these systems are not very good in generalizing about the training data, everything it's not part of the training data will only be at least approximately right. That's for sure.
Thank you very much.
Okay, I don't see the next question. Raise your hand. We have one here. Go ahead.
I have a question. It's about the experience with the table and the rows and all the columns. I seen the picture that you present that the bench has different height. So I'm just worrying if you calculate also the tall of the person to make sure that they have the right angle, or and also for the first row, are they able to touch to the object? So it will be a way to identify the distance between the pointing and the object that is that maximize the reception of the person.
Did you hear that, Andy?
Yeah. So you're asking about the distance and perhaps touching objects? Yeah, that's right.
Yeah.
The speaker or the pointer actually tended to touch or get very close to the objects in the first rows because they are simply in reach. That's the reason why in this short distance, pointing gestures were, well, kind of perfect for the addressee to identify. So yeah, you're right in this aspect. But the other thing was that there are different objects with different sizes and orientations and shapes. And yeah, this was on purpose. And so the this space of possible objects was not evenly distributed, if that's your question. That's right. But we did it because people used kind of iconic traits sometimes on top of pointing gestures. If they refer to a longish bar, they could use a pointing gesture like this, and so they sometimes did. And this was kind of interesting. I think there are other studies by Oliver Herbort and his lab where they had really dense displays of equal objects, though it's in task which is impossible to solve, but they look what people are doing nonetheless.
Okay, and what about the height of the bench where the person is sit? Do you calculate also the tall of the person to calculate the angle of the pointing when the object was formed?
Right. Yeah. Yeah, right. In simulating the pointing beam, or actually the pointing cone, we took this into consideration because we had the coordinates of the hand, and we had the coordinates of the table, and this could be done. The most interesting finding with regard to kind of anchoring the pointing cone or the pointing beam was that there are several alternatives. The naive one, or the most direct one, is to anchor the pointing cone just in the index finger, right? But this wasn't the best model. We found that anchoring the pointing cone at the intersection of the index finger and gaze was much more precise.
Okay, and last question, I'm sorry. In the text, you also say that you had only user with a red hand, but they have a glove on the two hands. So did you find a difference between the pointing if they use the left hand versus the right one?
Yeah, we did. So we asked every participant whether it's a left-hander or right-hander, and they used predominantly the right hand to point at objects. But sometimes, when the objects were on the left side of the table, they used the left hand to point to the objects, regardless of being left or right-handed people.
Okay, and not necessarily far or near.
Not necessarily far or near, right? Okay. It was a left-right thing.
With Steve Hansen.
Can you hear me?
Yep.
Good. Yeah, this was a great talk. I really enjoyed, especially towards the end here, their, I guess, inferences about the GPT representational structures and what they can or cannot learn, I guess. But let me not overstate your case. So tell me if I'm wrong. I think what you said was that the GPTs can be grounded in, let's call it reading, although that's a big stretch, I suppose, but text. Okay, it's fairer, but we could also say it's somehow reading. It's encoding for sure. But are you saying therefore, could there be perceptual or motor kinds of inferences drawn from episodic structure in the text that has, the proper reference? And I like your Wittgenstein reference here, because I think it does cause a lot of problems if Ludwig was around and trying to talk to one of these things. But do you get my confusion here at all?
Okay, let me. So what I think what I have said is that with this kind of grounding in in the associative or distributional sense, so it's not sensu motor. I think we agree on this. But if you have text describing movements, motor features, whatever, this is data concerning the referential domain, which of interest to you, and these descriptions alone may be sufficient for ChatGPT being able to discuss these things with you. And the question is then, so in principle, ChatGPT can learn anything. At least we are able to provide text descriptions for them. So is there something we can't talk about?
Yeah. So it's, given the amount of data, trillions of tokens and who knows, billions of conceptual structures, and internally there seems to be contextual information that if you do a kind of a projection, PCA or multidimensional scaling or something that people have looked at, it looks like there's, tens to 50 million different clusters in the space. Of course, that doesn't really account for other than the fact that it has a lot of contextual information from the text. And so that may not be too surprising. But what is surprising is, like in your example of the gesture with the finger, and the GPT-3, I guess, was saying, yes, elongated rectangular. These are inferences, aren't they? The question is not so much what it can absorb as knowledge and organize as knowledge, but how in the world is it doing inferential kinds of judgments about things that it could never see?
Yeah. The answer must be that there was descriptive, so written text input in the trillions of training data, where there is an association between certain directions, like this movement away from the body, left, right, and certain shapes. So there are some papers on gesture semantics where examples like this are discussed. So maybe
it read those papers. Yeah. So I mean, part of your proposition here suggests that we really need to track down the sources of these contexts and in fact, essentially understand what it actually has read, or what, so for instance, if there was a visualization that showed you from a query back to a bunch of sources that may have supported the response to that query, it might start making a little bit more sense. But right now, it responds in well-formed utterances, and it's drawing inferential logical conclusions. None of this is obvious from a device that learns to predict the next lexical item in a string of lexical items. I mean, there just isn't a precedent for that, for AI to have emerged from that kind of murky, messy, little prediction. So so in some sense, it feels like you're a little bit out over your skis here, but on the other hand, I don't disagree with what you're saying.
Yeah. These examples are, as I said, anecdotal examples. A large-scale, more systematic study would be nice, of course. I would suspect that there is some limit somewhere in gestures that cannot be described. Actually, I have, well, if I can just share my screen for some second once again. I think I have an example. I'm sharing, okay. It's here. Can you see this?
Yes.
Kind of weird movement, and it's really hard to describe, and it's really hard to classify what this should be.
Right.
Because this is not a lexicalized model, and this could be. I haven't tested yet this because it's very tedious to. But this could be a way to get somewhere.
Okay, let me try to give you a harder run for your money. Although, like Steve, I also at some level agree with some of the things that you're saying. Others I don't completely understand. The anecdotes at the end from Wittgenstein, the limits of my language are the limits of my world. That is completely agnostic as far as reference grounding is concerned, because it may be true of LLMs with big databases that contain a lot of discourse that comes from non-LLMs like you and me. I agree with Steve that we don't know how it is that it does the magic that it does with those, but it can do magic with just those words. But it can only do the magic with those words because it has those words, because words can actually express that. Let's simplify, express it. There are descriptions. It has descriptions. And everything that is described in the descriptions can be used in the descriptions. And it can also convey understanding to someone who hears, who interacts with GPT and is told the geometric story that is GPT's interpretation of what it is that the grounded listener really meant. But the grounded listener's capacity, when you say my language, I'm not GPT, I'm a person. I accept that the limits of my language, the limits of my language are the limits of my world. Everything that I perceive, I can describe in words on one condition, which is that my words are grounded for me and for you. LLM cannot say that. He can do it as well. Whatever words you've given him, if it contains the right description, the little one for that one nuance that you were testing in that example, he can do it. But not one of his words is grounded. It just does things that grounded speakers can do, and that words can therefore do. Now, you said that you in your summary of your article, you said that you were sort of pointing out some limits of the simple-minded notion of grounding, which is, just add a few sensory motor peripherals and you've taken care of it. That's a toy solution. You mentioned also P3, which is a real world solution. I'm willing to say it's T3, by the way, a robot. It doesn't have to be a person with flesh and blood. And it does have to be a robot which can do visual and auditory and tactile processing. But without that, an LLM doesn't have that. And the LLM wouldn't have it if it just had a TV attached to it as well. I hope you agree about that. Or do you? So in the end, state your real views on the relationship between the need for grounding and the performance capacities of LLMs. Because I couldn't discern it from what you were saying. You were giving examples that worked. You said that's pretty good and that's pretty good, but I leave the but it's but ... as in your
yeah, by some examples I was surprised myself that it worked. I haven't expected that. I can confess. So that's the magic you talked about. And I thought, why is this possible? Even though ChatGPT have never seen a gesture, it hasn't grounded concepts. And the answer, I think, is that you just need kind of local descriptive spaces to make sense of like spatial concepts or emotional concepts, because they are organized in certain descriptive subspaces of the whole huge space of LLMs. So this kind of sidesteps the cyclicity which is involved in the end. So you can just cut like symbolic or distributional grounding if you want.
It's not just cyclicity, it's complete circularity.
It's
but
complete
okay, Sabine has a question.
Thank you. That just sort of really continues this, your question and Andy's answer. First, I want to say that I think ChatGPT is not just an LLM. I think if we talk this philosophically, we must be a little more precise. And there's so much in ChatGPT that is not just the word associations that I think it's dangerous to say LLM when we say ChatGPT, because depending on how it's interpreted, that just makes things go sideways. But aside from that, what an LLM is, a real LLM like GPD, without the chat, and without the hand modifications that are added and all that, is essentially in my visualization, because it's an abstract thing, right? So I have a partial model of what it really is, and when I speak about it, it's even more partial than what I'm imagining. And what it is attention space, right? It is different things that are related to each other. And these are what we call the word models, and we visualize them being words, but it's really connections between it and all that. But what it really is, an LLM model, is something that has tension. And so if you were to ground, if you wanted to backwards ground it, right, and say, this here is a that, and this here is a that, it will fill in. In fact, that's the entire point of machine learning and of language models, that it has isolated, I can't say anything, it's all wrong. It's not experience, it's not data, but it has isolated points that it interpolates over somehow in that space that it constructs, right? It's a construct. And what I want to say here, and in a certain sense, I hate y'all for making me argue for ChatGPT here, but in a certain sense, I feel it's not unlike how we teach our children and how we talk to other people about conceptual. Here your talk, Andy, was much about motion, visual, concrete. That's not what language is for. We can do with grunting and pointing for that usually with people we see. You also omitted a little bit the here, which this is built with, right? But language is really when we talk about the abstract or the absent or the possible. And here, I wonder whether this is not actually this kind of tension of sort of isolated things. You know, I know, we have shared labels for, we interpolate between, and then we adapt by figure to communicate, right? That's not much of a question, so I want to say, what do you think of that?
Yeah. Let me try to see whether I understood you correctly. So it's true that the gestures are very concrete things. They are about concrete things. You can use them metaphorically, which would
not only. Notice, not only.
Yeah, I think if you use a concrete gesture, they are probably always concrete with something abstract in speech, which makes the gesture metaphoric. Or in speech, I think you can think in both directions.
Yeah.
But I don't see why this should be an obstacle to large language models. So they are fed with any kind of text, abstract text too.
No, I didn't mean it wasn't. I was saying it's actually because Stephen said a language model will never be grounded. And so it's just sort of working in its own world and never shall it know mine. And my question to you, because I haven't played a whole lot with these large language models in that sense, is would it possibly come to have a partial sketch of my world if I were to ground somehow very few labels only because of that tension that it has in its world, that it has taken from other people, what other people said?
Okay, I see. Yeah. I think this is really a question, if I don't misunderstand you, I think this is a question about these multimodal language models, which do exactly this. They use text and enrich this by means of whatever, classically pictures, but you can think of everything, smells, videos. Yeah. And yeah, as far as one knows, adding data is always good. So these models, these multimodal models perform better than just text-only models. But I think there's a caveat here. You can probably use text models without other modalities, but I'm not sure whether it works the other way around. You can use other modalities without text, because this is kind of the descriptive anchor you need for making sense of any patterns you may find in other modalities too.
Unfortunately, we're running out of time. We have run out of time. So what I'd like to say is that this will not end with this winter series. There will be a 2-week summer school with some of the same speakers and many new speakers that will continue this and continue it in a much more concentrated way because it has to be digested and disseminated. So I want to thank Andy very much for his talk. And Andy will be one of the people that comes back in June. And next week, I invite you to continue with the fall series. Thank you, and bye-bye.
Thank you.
Thank you.
Bye.
Bye-bye.
Bye.